Now I am going to transfer function. This is a terminology or phenomena which relates input and output in a system. And the definition is Laplace transform of output by Laplace transform of input. And the thing what I explained earlier, this is the system. And we will give some input x of t, output is y of t. If you apply Laplace transform, it is x of s, y of s. Inside the system behavior, I will represent using h of t. System behavior, I will represent using h of t, which is called impulse response. H of t is called impulse response. If you apply Laplace transform to that, it is called h of s. It is a capital letters. After applying Laplace transform, it should be capital letter representation. X is capital letter, y is capital letter, h is capital letter. In the time domain, we have to use small letter x, small letter y, small letter h. Okay. All these things in time domain and frequency domain. This is frequency domain and this is time domain. And what we are telling, the transfer function is nothing but Laplace transform of output by Laplace transform of input. So this side, these are output parameters in time domain, output parameter in frequency domain. This side, it is input parameter in time domain x of t, input parameter in frequency domain, which is x of s. Now transfer function is nothing but Laplace transform of output divided by Laplace transform of input, which can also be called as h of s. Other name for transfer function is system function. And one more name is also there, frequency response. All these are other names for transfer function. Okay. And if you see the ratio transfer function, it is relating input and output. Transfer function is giving fraction between input and output. So it is some relation between input and output. And here comes the role of Laplace transform. And if you see the diagram on the right side, why Laplace transform? In time domain, we will write some equations to represent the relation in time domain. For example, I can write y of t equal to x of t plus dx of t by dt. First order derivative I am writing. Then 2 times I will just derivative the input with respect to time. 2 times like this derivative. This is called differential equation. This equation number one. This is also relation between input and output. Just an example, whatever I thought, just like that I have written. Okay, this is an example for relation between input and output. There may be a system which is giving output y of t based on the relation like this, equation 1. And the name of this equation is called differential equation. This complete equation is in time domain. You can see this complete equation is in time domain. So if you see the diagram on the right side, time domain, unknown f of t d by dt, differential equation, solving the differential equation, time domain f of t. And when you apply Laplace transform, it will be converted to frequency domain. When you apply Laplace transform, time domain is converted to frequency domain. Differential equation will be converted to algebraic equation. In frequency domain, after applying Laplace transform, the differential equation in time domain is converted to algebraic equation. We will solve the algebraic equation and we will get the frequency domain f of s. Here h of s we are having, which is called transfer function. If we want time domain again, we have to apply inverse Laplace transform. So forward direction, it is Laplace transform, which will convert time domain to frequency domain. Reverse direction, it is inverse Laplace transform, which will convert frequency domain to time domain. Nothing, no by heart